Next problem, the following data obtained from a 2 square factorial design replicated 3 times, right? Evaluated the sum of the squares of all factorial effect by the contrast method and draw conclusion. Total number of items n is equal to 12, n small n replication 3. There is no difference between mean effect, that is AB, AB. There is a difference in the mean effect. Shifting the origin to 20, so subtract 20 from each and every numbers in the given data, so you will get the new data. So we are going to use this data, right, for our calculation of ANOVA. So ANOVA calculation, treatment combination bracket 1 A, B, AB. So here we are using A, small a and capital A, both are same, right? Don't get confused. Instead of small b, sometimes I am using capital B, right? So values, number of replication 1, 2, 3. So I am using the revised data from the previous table. First to find the row total, first row total, adding the number in the first row you will get minus 19, second row minus 9, third row minus 3, fourth row 10. Then sum of squares. So before that you find the grand total, add the all row total, you will get the G grand total minus 21. Then sum of squares, square the numbers in each row and add up. Minus 8 square plus minus 1 square minus 10 square. So 165, 41, 41, 106. Total sum of square, double summation xij square, that is equal to 353. First contrast A. Before that correction factor G square by n, that is equal to 36.75. A contrast formula AB minus B plus A minus 1. So take the row total corresponding to AB, B, A and bracket 1. So write the numbers here, so you will get the answer 23. B contrast, so same using the row totals, right, against to that bracket 1 A, B, AB, that is the value written here, right? Minus 3 plus 10 minus 9 minus 19, that is equal to 35. Then AB contrast, that is equal to 3. Total sum of square formula, take it from the table, right? 21.2. Then contrast A, sum of square A, ASS, which is equal to 44.08. Then contrast B, sum of square BSS 102.08. Then contrast AB, sum of square ABSS 0.75. Then error sum of square, which is equal to 169.34. Then prepare the ANOVA table. Source of variation small a, small b, small ab, then error. Instead of small a, small b, small ab, so already there in the previous table, so that is what I am using capital A, capital B, capital AB. So no problem with that, right? Sum of square ASS, because you can easily write ASS because I am using capital A, BSS, ABSS, right? That, right? So error sum of square. Then degrees of freedom, AB, A comma B and AB all 1. Then error n 4 into n minus 1, 8. Then mean sum of square ASS by its degrees of freedom. So ASS only 44.08. Then BSS only for mean sum of square 102.08. Then ABSS also equal 0.74. Then ESS will differ because degrees of freedom is 8. So divided by 8, so 21.17. Then variance F. So F test, FA is equal to MESS by MESS 2.08, FB is equal to 4.82, FAB is equal to 28.23. Right? Then conclusion, factor A calculated earlier 2.08. So tabulated value degrees of freedom 1,8. FT is 5.32. So FA is less than FT. Right? Therefore FA is accepted 1. Null hypothesis is accepted. Calculated is less than tabulated. Next factor B. So calculated value 4.82, tabulated is 5.32. So calculated value of B is less than tabulated value. Therefore here also null hypothesis H0 one is accepted. Then factor AB, calculated value 28.23, so degrees of freedom 8 comma 1, and the tabulated value 16.1. So in this case H naught 1 is rejected, AB case, right, because calculated value of AB is greater than tabulated value. Thanks.